Hello, everyone, and welcome to another episode of Coffee Chats with Claire. I'm so excited to welcome Maria-Belen Perez-Ramirez, who's my mentor at my internship. She got her PhD in biomedical sciences from the Institute of Cell Physiology at the Autonomous National University of Mexico. Currently, she works at the Knowles Lab at Stanford, and I'll allow her to tell us more about her work. So let's dive right in and talk about what you're working on right now. Can you please tell me about your current role as a basic life research scientist in the Knowles Lab?
Sure. Do you want to know more about the science in general, or maybe like what I do in the position?
I guess you can talk about both.
Okay.
Whichever one you think is, yeah.
Well, I think it's super interesting. Like what I'm doing in research, we're studying a model of absence seizures, generalized absence seizures, and something I learned when I started studying epilepsy, and I think that that's a misconception for everybody, is that there's just one type of seizures. But no, like there are so many types of seizures, and then this specific type that we are studying, um, it's normally expressed in kids, and they lost consciousness. So while they're having seizures, they are unconscious. So you cannot really tell what's going on. And then these seizures happen so fast, like in 1 second, that most of the times parents don't notice until like it's like advanced or pre-advanced. So what we're doing in the lab is in this like we are studying a model, and in this model we are studying what are the mechanisms specifically in myelination, or also like in general or more general the immune response. What's the role of the immune response in in doing the epileptogenesis or epilepsy progression? So if the immune system has a role, and then what's the role in seizure progression?
That's very interesting. And can you walk me through like a typical week or a day in the lab and some of the responsibilities and common tasks that you handle?
It varies. It varies a lot. Sometimes I will doing more managing stuff. Um, I will be reading papers. I will be doing or writing protocols. I might be doing, yes, like some writing. It could also be like grant writing. I could be planning experiments. I could be doing experiments. I really enjoy doing hands-on experiments. We can do surgeries. We can record the brain activity. And then I can also be doing analysis like what you did, that you will be doing the analysis of
The
the
EEGs, yes.
EEG recording, yeah, the electrogram recordings, and so many things. Like I also really like going to another lab meeting. So some days I will also be doing another lab meeting. We have our own lab meetings, and then we also have a bunch of meetings, which sometimes could be too much because they take a lot of time. But some other times it's really nice to have meetings because then you get to discuss your science and what you're doing, and yeah, like it's nice and refreshing to also have like these meetings. So
It's nice that there's like so much variety within like what you do, so you don't really get bored. There's always something to do.
yeah, you never, and then you also get to know really amazing people that also likes science from all levels, like you, for example. Like that's very interesting. Like you are meeting new people, nice people. So it's very enriching. I really like it.
Yeah, absolutely. And I also feel like everyone's just passionate about certain topics, so you get to like bond over that too. So it's very special.
Yeah. Yeah.
Can you share a positive outcome from your epilepsy research that you're particularly proud of?
Um, Maybe I can talk about like the latest. I mean, there are several things that I'm proud of, but maybe the latest, it's I got in this lab where I'm working now, where you did your internship. we like I like doing like electrophysiological recordings, which means that you are seeing the function or electric activity in general, like neurons or systems, networks. So I I got the challenge to propose an experiment to answer a question regarding whether or not the corticothalamic circuit, um, I might be getting like too technical, but regarding whether or not there were differences in the conduction of one circuit. So at the beginning, I proposed something and it didn't work. Um, and then I came up with another idea, and that one was like a really cool idea. Like Juliet and our collaborator received it very, very well and enthusiastic, and I got to learn how to do that, which are the callosal recordings, so the compound action potentials, where you can see the activity of the myelinated fibers. Myelinated fibers are part or conform the white matter tracts in the brain. Well, not only in the brain, like in the um, nervous system, but I was studying it in the brain. So that was really cool that I got to learn how to record this type of activity, and that I got to find that the conduction velocity in in the seizure phenotype was increased compared to normal phenotype. So yeah, that was very exciting, and I learned a lot. I learned to do the analysis, so that was very, very enriching. I really like it.
Yeah, and it was so cool that when I saw the diagram as well, you could see that the myelinated and then the unmyelinated is later on. So it was
Yes, it's called a biphasic response. That it has like two phases. So yeah, it was cool. That was something new that I learned, and that I had never thought about that. But it was really nice.
what do you think are some of the more pressing issues in your field of work, and how do you think that they can be addressed?
Yeah. uh, so epilepsy, I think one of the biggest problems in epilepsy is that we don't have a cure, or we don't have a way to stop seizure progression. There are a bunch of drugs slash medicines that they help stop seizure, like they just help stop symptoms, but there's nothing that helps you like reverse or cure epilepsy or stop epilepsy. So I think that's one of the biggest challenges. And also, like it's very, like it's very complex. It's a very complex condition, because it's being studied since like way back. It's, I think it's maybe one of like around the first conditions that was started to being studied before. And even though to this date we still don't understand what's going on and how we can reverse it, if it's possible to reverse it. And then we have some clues, but we are still not there yet.
Right. So, but do you think like with the new incoming technology and everything, the process will speed up faster and you guys will make more progress quicker?
I don't know. I hope. I mean, yes, I have hopes that it will be at least that we find something that it could help, like seizure progression, that maybe we can identify, like there are a bunch of clues, like biomarkers. That's how we call it, biomarkers that we know, but we still don't understand, because it's, as I said, like it's a very complex condition that is not just affecting, like for example, excitation, that there is more excitation and there's less inhibition. And then, as you know, like there are other type of cells involved. And then now, like lately, it's not that recent, but let's say it's recent in comparison to the whole time this is being studied, that people realize that there's also a role for the immune response. But we are working, like there are several works working to find out what's happening and then when to stop, for example, the immune seizure, the immune response. So yeah, it's challenging, but yeah, I think for sure, of course, like new technology is helping to advance.
I'd love to rewind a bit and hear more about your journey. So, where were you for high school, and when did you become first interested in neuroscience and brain research?
I was When I was in high school, I was still living in Mexico. Um, I think I knew I wanted to study something related to biology when I was young. Let's say maybe, yeah, maybe around when I was starting high school. I really like, I have a really cool teacher, Emma. So, and she was very passionate about biology. So I was really lucky to have her. Um, but then when I needed to decide what to do for my undergrad, oh, and then I have maybe you, like in your generation, you don't know it, but the person that started National Geographic was a French guy that was diving, and then he was describing everything from the sea. So when I was young, we used to have these VHC videos that I used to watch with my family, and he was like diving and describing sea life and everything from the sea. And I thought, oh, I want to do that. Like I want to be a marine biologist. So that was like, I need to do that. But then, yeah, and then this teacher came and she was like, yes, like you should do it if you want, blah, blah, blah. And then when I went to these fairs, um, like career fairs, I talked to a biologist and he gave me one of the greatest advice I think in my life because he said, "Why don't you study general biology and then you will have the whole background, and if you really feel that you love marine biology, then you can specialize on that and you will have the whole background and that will be helpful and yes, helpful for you." And I said, yeah, that's a great. So I pursued to study biology. I studied biology, but then I had a requirement also at sort of the end last year of my undergrad that I needed to make a project. So that project gave me, like, it was a great experience because I went to another lab, I traveled abroad, and they were studying neuroscience. I started focusing on neuroscience from before, but then there I found it very interesting that they were physicists and they wanted to understand whether a physical stimuli, just light, will help neurites grow. Like if but, but I was doing some like cell cultures and I was studying also like C. elegans, and I was like, this is interesting. So when I came back, I was trying to find out, like I finished my undergrad and I was trying to find out what to do next. So somebody recommended another lab and they were studying basal ganglia. So basal ganglia, I learned like when I was like, what is this? I have no idea. So I did some research and then I learned that basal ganglia in the brain are involved to learn repetitive movement. And I'm a long life dancer. Like I danced since I was 3 years old. And I was like, oh, this is so cool because then I will get to study the part of the brain that is in charge or related to learn repetitive movement, which relates So when I'm learning new choreographies, like this part of the brain is involved. And I was like, oh, so I went to that lab. I talked to the PIs. They received me, and they were focusing on studying Parkinson's disease. So that was really nice. So that's my whole journey, how I got to neuroscience. Like neuroscience was the link between two of my passions, with are like, yes, doing research. And then that way I started being also passionate about neuroscience and dancing. So
Amazing. And did you ever face any like significant challenges earlier in your career, or did you overcome anything?
yeah, I had a lot of challenges in general, but I think one of the hardest, when I learned how to do patch clamp. Patch clamp, it's the technique where you are literally seeing the activity of a single neuron. So you touch a neuron with something that looks like a straw, that it's glass, but it's like a straw, and you break into a little or tiny bit of the membrane of your neuron, and then you get access to record the activity, electric activity of this neuron. So when I was learning that, I spent a whole year without a single recording. And I was very glad that my PI by that time, like, she didn't say like, no, you're not good at this. But every single day I was recording from 9 a.m., or I will start at around 8 a.m. in the morning in average, to 5, 6, even 8 p.m., depending on my activities of the day, like trying to get a single neuron. And I spent a whole year without a single recording. And I was checking everything, like solutions, preparation, like everything. So one day, I don't know what happened. One day I started like getting recordings, successful recordings, really nice recordings. But something nice is that during a whole year, I was able to learn how to troubleshoot a bunch of things. Um, I think, like, looking back, it was highly frustrating, but yeah, looking back, it was a very enriching learning experience. So yeah.
Yeah, that requires a lot of determination.
Yeah. Yeah, so yes, yeah, so that might be one of the biggest challenges maybe that
Is
I
patch
face.
clipping like universally difficult? Do a lot of other researchers also? Yeah.
Um, Normally, yeah, people who know electrophysiology and what it requires, like they will, if yeah, they will know the challenges. So it's one of the most difficult techniques, I think, in neuroscience, or I would say in neuroscience, and it requires a lot of time. Not many people like to do that. Um, So, but it's very satisfying.
Yeah, that's actually really amazing to see the like activity within just one singular neuron. That's
Hmm.
impressive.
Yeah,
And how do you handle these kinds of uncertain outcomes, or maybe you have some high pressure situations? Like, what would you tell yourself?
yeah. I think it depends on the personality of everyone, but for me, I'm highly perseverant, and then I feel I'm super, like, res- I feel that I'm responsible. Like, when I give my word that I will do something, is that I have to do it. So so yeah, I think that every day I was just there trying to patch. So I think also my PI saw me working. So I'm very perseverant. I think I'm highly tolerant. Um but yeah, I think several times I was just like, I'm useless. I should just stop. But then something also that was helpful is that I was doing another activity, like I was dancing. And at that time, when I was doing my PhD, um, I felt I was so good. Like that was my best time in dancing. So at least I had that motivation. So it's like, okay, I'm good at this. So maybe find your hobby where that gives you a lot of satisfaction. So I think that was something good for me, that I had another activity that I feel I was good at and I was very passionate and gave me a lot of satisfaction, that I was like, okay, it doesn't matter. Like at the end of the day, I was going to my ballet class and I was doing great there. So yeah, everything, I forgot everything and I was able to restart the next day.
Yeah, I totally agree. I think that's so important to have like an outlet, or like some other hobby to like separate work and personal life. So that's great that you had dancing.
Yeah, yeah. And friends. I mean, in general, also friends. Yeah, it's a good support.
And to close, I would like to ask you for more advice. So, what advice would you give to someone in high school who is interested in pursuing a career in research?
I would say first try to understand if you really, really want it and what your motivations are. Try to understand also your principles, um, and see if you are like tolerant to frustration, because normally in science is not that straightforward. Like it's always a very convoluted path, and you need to invest a lot of time. Normally, like you will work doing experiments and then come back and do more research, more reading. So if you, and yeah, normally it takes a lot of time, a lot of your time. So understand and be very honest with you if you are feeling like really passionate and this is something you like, because it will take a lot of your time. Then another thing is that learn coding. That, like, I don't know how to code. Well, I have some idea. I have some idea. But coding will make your life super easy. So if you learn how to code and you like to play with coding, it will make, in science, it will make your life easy. What else? Like math. If yeah, try to, like, it doesn't matter if you go to psychology, medicine, uh, clinics, or anything related to research. It's very useful to know and understand math. Um, yeah, I mean, yes, like math, it's very important. And I think also reach out. Don't be shy. Just contact people in research. Write to them. Maybe if you see them in LinkedIn and you contact them in social media, I don't know, like just write to them. Try to talk. Like if you are indecisive, like you are deciding if you want to do it or not, try to reach out to scientists and then ask all of the questions, like life balance, I don't know, motivations. Yeah, what you're doing, Claire, like what you're doing is great,
Yeah,
but
shout
how
out to
does a
you for
day look
answering
in
all my
yeah.
questions. So, yeah.
Yes, so yes, maybe keep on watching the like Claire's podcast, but this is like, this is a good, yeah, this is good, so you know what you're going into, because sometimes you have no idea what you're going into. Also, like for the field that you are going to, try to find out what's the job offer, because sometimes you can be super passionate, that helps a lot, but sometimes in the path, like you might need to know, or you might need to decide where to work. So that can also be something important.
Right, you got to stay open-minded and flexible because there's
Yes,
no
yes,
direct
yes.
path.
Yeah.
Yeah,
And
that's
yeah, like don't be shy, contact people, like buy them a coffee or just tell them like, hey, give me 5-10 minutes of your time. um, and maybe also when you are already working with scientists, don't let them do your work. Like, try always to be one step ahead. If you need a letter of recommendation, for example, come up with a draft and tell them like, hey, I will need a letter of recommendation. Um, would you be willing to? And then if they say yes, then tell them like, oh, I can come up with a draft for your revision, and then you can decide what's in it. So, but try always, like, when you are asking for something, like, try to like be your best and give it all. So, yeah.
And is there anything that you would do differently looking back on the path that you took?
No. No, I really, well, there's been lately like some, I would love to have, like, I was, I was already accepted into one of the most famous traditional ballets in Mexico City. But then I was at the time that I was writing my PhD thesis. And then I said, I'm not going to accept, because I went to the audition. They took me, they told me, yeah, now, like, you. But then I thought, ah, I'm going to be like super passionate about dancing and I will not give enough time to write my thesis. So I didn't talk to any other friend. I just took the decision almost right in the same time. And I was like, maybe I would have been able to do both. Like, I was just like not thinking much and I just took the decision on the time. But there's always time. So keep that in mind. Don't, like, if you are not sure about something, just ask for time. Don't take decisions right away. So think about your decisions. There is time. And that's maybe the only thing I'm like, ah, I should be able to do those, like, both. But anyways, but yeah, just, yeah, yeah. Take
That
time
makes a lot
to
of
think
sense. Yeah.
about your decisions.
And then is there anything else that you'd like to share with our audience or any final thoughts you'd like to leave us with?
No, maybe I can give you my Instagram or something, and then if somebody wants to talk and know more or like discuss anything, I'm happy to. So yeah,
Thank you so much, Bella, for speaking with me today. This is very productive, and thank you so much for all your insights.
I hope it's helpful and useful for everybody.
It is very. So, and to our audience, thank you for joining us on another episode of Coffee Chats with Claire. See you again next time.